Welcome everyone to this first session of our Sust Agri course. We're about to dive into a topic that's, well, absolutely critical for our future, agricultural hydrology. Over the next few minutes, we're going to tackle a few key things. First, we'll break down the core components of the water cycle. Then, we'll explore how agriculture really profoundly alters it. And finally, we'll connect the dots to see why this knowledge is so crucial for sustainable food production in the 21st century.
Okay, let's kick things off with a question that sounds simple, right? When rain falls on a farm, where does all that water actually go? But, the answer is surprisingly complex. And this question, it's really the core of what we're going to be talking about. Because in farming, every single drop counts.
So to even begin to answer that question, we need a framework. And that's exactly what hydrology gives us. You see, it's the science that helps us understand how water moves. And it's so much more than just, measuring rainfall. It's about a deep, integrated analysis of water's journey, how it moves, how it changes, and where it's stored all across the landscape.
Now we're going to narrow our focus a little bit to agricultural hydrology. And this is where things get really interesting. Because we're not just looking at how farming uses water, we're looking at how it completely reshapes the entire water cycle. And to do that, we have to pull from all these different fields. We're talking soil physics, plant science, even engineering. It's all about figuring out how our actions on the farm impact this incredibly vital resource.
Okay, so let's pop the hood and look at the real engine of hydrology, and that is the water balance. Really, the best way to think about it is like a bank account for water. It's the tool we use to track every single drop that comes in, every drop that goes out, and what's left in storage within a specific area, whether that's a single farm or an entire watershed. And here it is. This equation might look a little technical, but honestly, it's the backbone of everything we do in hydrology. At its heart, it's just a simple idea of conservation. What comes in has to equal what goes out plus any change in what's stored. That's it. Every single thing we're going to talk about fits somewhere in this elegant little equation. So let's break that down piece by piece. First, you've got your inputs. This is the water coming into the system. Think rain, that's precipitation, or P, and any water we add ourselves, which is irrigation, or I. Then you've got your outputs, the water leaving the system. That can be evapotranspiration, ET, going back to the air, or runoff, Q, flowing into rivers. And finally, and this part is so important, we have storage. That's the change, the delta S, in how much water is actually being held in the soil reservoir. All right, let's zoom in on one of those key outputs, evapotranspiration, or just ET. In most farm settings, this is the biggest way water leaves the system. Now, it's really important to know it has two parts. You've got evaporation, that's water just disappearing from the soil surface, which doesn't really help the plant. Then you have transpiration, that's the good stuff, the water the plant breathes out while it's growing. So a huge goal for us is to shrink that evaporation and boost the transpiration. Make the water work for us, right? And what about that other big output? That's runoff. Basically, this is what happens when it rains so hard the soil just can't drink it in fast enough. The water has nowhere to go but sideways. And here's the thing, it's not just lost water. This is a powerful, destructive force. It's literally stripping away your precious topsoil and carrying away nutrients, and sometimes, unfortunately, pollutants straight into our rivers. So yeah, managing runoff is a huge deal. Okay, so we've got the basic accounting system down, right? The water balance. Now let's get to the really transformative part. We're going to see how agriculture doesn't just, play by the rules of this cycle. It actively rewrites the rules. It reshapes the whole thing, often on a massive, massive scale.
And when I say massive scale, I mean it. Look at this number, 70%. That's how much of the world's freshwater withdrawals are used for agriculture. Let that sink in for a second. 70% of the water we take from rivers, from lakes, from underground aquifers goes to farming. This single number, it puts agriculture right at the heart of any conversation we have about global sustainability.
So, how does this reshaping happen on the ground? Well, just look at the difference when we change the land use. Think about converting a natural forest into an agricultural field. Suddenly, every single part of that water balance equation we just talked about gets thrown for a loop. Infiltration, the soil's ability to soak up water, it often goes way down. Runoff, it gets faster and there's more of it. And the soil's capacity to act like a sponge, to hold that moisture, that changes completely too.
And probably the single most powerful tool we have for changing that cycle is irrigation.
I mean, this is a direct, deliberate intervention. We are literally adding a huge, controlled I into our water balance equation. It's what allows us to grow crops where the rain isn't reliable, to protect against drought. It's a complete game changer for the natural balance.
But here's the catch. Not all irrigation is the same, not even close. The method you choose has huge consequences for water use. Take a look. You've got old-school surface irrigation. Think flooding a field. It can be super inefficient. You lose a ton of water to runoff or it just sinks way past the roots. Then you move to something like a sprinkler, which is a bit better, but you can still lose a lot to evaporation. And then you have modern drip irrigation, which is incredibly precise. It delivers water right to the roots, drop by drop, cutting way down on those wasteful losses.
And it's not just about adding water either. Think about something as simple and common as tilling the soil. This has a huge effect on hydrology. You see, there's this trade-off. Right after you till, the soil's all loose and fluffy, so it can absorb more water. Great, right? But over time, doing this again and again can actually break down the soil's structure. It can form this hard crust on the surface, which seals it off. And what happens then? Less water gets in, and more of it just runs right off the top.
So, this all brings us to the big so what question. Why does this all matter so much? Well, getting a handle on these concepts is absolutely critical, because what we're really talking about here is sustainability, and the stakes could not be higher when it comes to how we use water in agriculture. Because when we get this stuff wrong, the results are frankly disastrous. And it goes way beyond just wasting water. We're talking about real-world problems. You can lose your entire crop because the soil is either bone dry or completely waterlogged. You get massive soil erosion that degrades the land, sometimes for good, and you end up polluting our rivers and our groundwater with all the extra nutrients and chemicals that get washed away. And that's why one of the absolute primary goals in this field is to improve what we call water use efficiency, or WEU. This is our key report card. It's the metric that tells us how much crop we're getting for every unit of water the plant uses. It really boils down to getting more crop bang for our water buck. We want to make sure every single drop that gets used by the plant is contributing as much as it possibly can to the food we harvest.
So in the end, what is all this knowledge for? It's about empowerment. It's about having the tools to be proactive. By understanding and managing these water processes, we can start to design farming systems that are smarter and much more resilient. And we need them to be resilient because they have to be able to ensure our food security in a future where, let's face it, the climate is only going to get more variable and more unpredictable.
So, to wrap things up, I want to leave you with a question to think about between now and our next session. Take everything we've just talked about and apply it to where you live. If you could change just one single farming practice in your home region to make its water cycle healthier, what would you change? And more importantly, why? What's the hydrological idea behind your choice? Think about it, and we'll pick it up from there next time.